Welcome to the Deep Dive. We're here to cut through the noise, transform that complex information into clear, actionable knowledge. Really give you that shortcut to being truly well-informed.
That's the goal.
Today, we're diving into some foundational concepts in artificial intelligence. We're talking AI governance, operations, auditing, the whole picture.
Yeah, the essentials.
We've got a set of specific questions and detailed explanations. We're going to unpack each one, guide you through the nuances, and really pull out what you need to know in this field.
It moves so fast, right?
It really does. And this isn't just trivia. We're hitting key areas: AI governance, risk, operations, audit techniques. It's not just knowing what's right, but understanding why it matters in the big picture of deploying and overseeing AI.
Okay.
We'll cover quite a bit, from model integration, ethical points, data management, even incident response. So let's maybe start by laying some of that groundwork. Absolutely.
Yeah.
Let's dive right in. First question, and it feels pretty fundamental. When you have an AI model, maybe it's been trained, developed. What's the primary goal when you integrate that model with a software system?
Okay.
Is it A, to enhance the model's capability to learn?
Yeah.
B, to secure the training data? C, to reduce computational resource requirements? Or D, to facilitate better user interaction and application? You might think it's about making the model smarter, option A, right? Or maybe efficiency, like C.
Yeah, those are common thoughts, but the correct answer here is D, to facilitate better user interaction and application.
Okay, so unpack that for us. Why D?
Well, think about it. Integration isn't really about the core training or learning phase. That's largely done. Integration is about taking that developed intelligence and making it usable. It's the bridge.
The bridge, right.
It enables the user inputs, the outputs, making the model accessible to whoever needs to use it. Think of, say, a self-driving car AI. The model itself is brilliant, right?
Yeah.
But integrating it with the car software, the steering, brakes, the dashboard, that's what lets a person actually use it, experience the AI. It connects the brain to the body, so to speak.
Okay, so A is wrong because learning is mostly pre-integration.
Exactly. Learning happens primarily during training. Integration is more about deployment. B, data security. That's crucial throughout the whole life cycle, not just integration. It's broader.
Got it.
And C, reducing resource needs. Well, optimization might happen, but it's usually secondary to the main goal, which is making the AI work for the user.
That makes a lot of sense. So what this means for you listening is that AI isn't really useful until it's accessible. It highlights that practical, human-centric side of AI.
Precisely. It has to connect.
Okay, great start. Let's move to the next one.
Yeah.
This shifts to a more strategic view. What's the biggest advantage of using an artificial intelligence or AI framework within an enterprise?
Frameworks, yeah. Important topic.
So the options. A, facilitates rapid adoption of AI tech to increase revenue. B, make sure human-in-the-loop efforts are maintained. C, ensures AI initiatives align with organizational goals and values. Or D, helps AI solutions increase customer satisfaction.
Right. Lots of potential benefits there.
They all sound pretty good, honestly.
They do. But the biggest advantage, the most foundational one, is C. Ensures AI initiatives align with organizational goals and values.
Alignment. Okay, why is that the top one?
Because a framework provides guidance. It's like a blueprint, a strategic plan for AI within the company. It helps ensure that AI isn't just happening in isolated pockets, cool tech projects here and there.
Right, avoiding silos.
Exactly. It ensures that AI efforts actually support the core mission, the values, the overall strategy of the business. It keeps everything pointed in the same direction. It can be adapted, of course, for each organization.
So it's less about the immediate wins like revenue or customer satisfaction and more about the strategic fit.
Well, those things, like A and D, are often outcomes of good alignment. A framework can speed things up and boost revenue, but the alignment is what makes that value sustainable and strategic.
And B, human in the loop.
HITL is important, operationally, definitely. But a framework's primary advantage is that broader strategic guidance, not just one specific control mechanism.
Okay, that clarifies it. It's like a business plan, but specifically for AI. It raises that key question. How do you make sure AI truly serves the organization's purpose?
That's exactly it. It's about ensuring AI isn't just tech for tech's sake.
All right, let's tackle a specific type of AI deep learning. What is the primary risk associated with using deep learning, or DL, models in business-critical applications?
The DL risks.
Options are A, inability to explain the decision-making process. B, the high cost of implementing DL models. C, the time required for pre-processing data. Or D, limited scalability across different platforms.
All potential challenges for sure.
Especially when we say business critical, the stakes are high.
And that's why the answer is A. Inability to explain the decision-making process of the model. The famous black box problem.
The black box.
Yeah.
Tell us more about why that's the primary risk.
Because in critical applications, think finance, healthcare, legal way, you have to be able to understand and justify decisions. If an AI denies a loan, suggests a medical treatment, or flags something legally and you can't explain why.
Big problem.
Huge problem. You can't audit it properly, you can't defend it against claims of bias or error, you can't ensure regulatory compliance, it erodes trust completely.
So cost, B, pre-processing time, C, scalability, D. Those are practical hurdles, but less fundamental than the explainability issue in critical contexts.
Exactly. Cost is a factor, data prep is work, scalability matters, but none of those undermine the core trustworthiness and accountability like the black box problem does, especially when decisions have major consequences.
So what this means for you is the growing importance of explainable AI, or XAI. Understanding the why is becoming just as crucial as the what.
Absolutely. It's moving from a nice-to-have to a must-have in many fields.
Makes perfect sense. Okay, let's pivot to data. This is crucial for keeping AI effective over time. Which of the following best mitigates the effects of using outdated data in training AI models?
Data freshness, yes, critical.
Options. A, integrating new information retrieval techniques. B, increasing the use of past data in training. C, strengthening data access security protocols. D, ensuring datasets include high-quality data.
Right. How do you keep the model current?
Seems like D, high-quality data would be important.
High quality is always important, but it doesn't solve the outdated problem. The best answer here is A, integrating new information retrieval techniques.
Okay, explain that. How does that help?
Because AI models are only as good as their data. The world changes, that's data drift. If your model is trained on old data, its understanding becomes stale. It's like using an old map.
Right, the GPS analogy.
Exactly. Even if the map was perfect then, it's useless if new roads exist. So you need ways to continuously integrate fresh, relevant data. New information retrieval techniques help ensure the model gets updated.
So option B, using more past data, would actually make it worse.
It could, yes. It would just reinforce the outdated patterns. C, security is vital but doesn't address data freshness. And D, quality is essential, but even high-quality old data is still old data.
Got it. It highlights the dynamic nature of AI. It needs continuous feeding, continuous learning.
Precisely. Effective AI systems aren't static. They need mechanisms to stay current with reality.
All right, let's solidify a core concept. What's the primary difference between supervised and unsupervised learning in AI models?
A fundamental distinction. Okay.
Options. A says supervised uses random guessing, unsupervised needs labeled data. B says supervised labels after predicting, unsupervised categorizes pre-labeled inputs. C says supervised uses unlabeled, unsupervised uses labeled. Or D, supervised learning uses labeled data for training, while unsupervised learning finds patterns in unlabeled data.
Okay, some of those are definitely confusing the concept.
They can sound similar if you're not careful.
The correct one, the fundamental difference, is D. Supervised learning uses labeled data. Unsupervised learning works with unlabeled data.
Labeled versus unlabeled. Can you give us a simple way to think about that?
Sure. Supervised learning is like learning with a teacher providing an answer key. You give the model data where the right answer or category is already known labeled. Think images tagged cat or dog, or emails marked spam. The model learns to map inputs to those known outputs.
Okay, learning with answers.
Right. Unsupervised learning is more like exploring on your own. You give the model a big chunk of data with no labels, no predefined answers. Its job is to find hidden structures, patterns, or groupings within that raw data.
Like finding clusters of similar customers.
Exactly. Clustering is a classic example. Or dimensionality reduction, simplifying complex data. It's about discovery, not prediction based on known answers.
So the other options, A, B, C, they just fundamentally mix up which type uses labels and how.
Pretty much, yes. They misrepresent the core relationship between the data labels and the learning process.
That's a really clear distinction. It helps you understand why some AI needs tons of pre-categorized data, while other types can just explore raw information. It's about how the AI sees things.
Precisely. Guided learning versus independent discovery.
Okay, now for something pretty cutting edge. Generative adversarial networks, or GANs. They're known for creating incredibly realistic data. How do GANs enhance this ability?
GANs, yeah, fascinating tech.
Is it A, by training components simultaneously to improve authenticity. B, adding more layers to the neural architecture. C, employing grouping methods to classify data. Or D, leveraging trial-based learning for iterative rewards.
The magic of GANs really comes down to A, training components simultaneously to improve authenticity.
Simultaneously. Tell us about these components.
So a GAN has two parts that are, well, adversarial. They work against each other. There's a generator network that tries to create fake data, like a realistic-looking face that isn't real.
Okay, the forger.
Right. And then there's a discriminator network. Its job is to look at both real data and the fake data from the generator and decide which is which. The critic.
Ah, the forger and the critic.
Exactly. They train together in this constant battle. As the generator gets better at faking, the discriminator has to get better at detecting fakes. And as the discriminator improves, it forces the generator to make even more realistic fakes.
It's like an arms race between them.
It is a zero-sum game. That simultaneous, competitive training is what pushes GANs to produce such highly authentic synthetic data. Think deepfakes, realistic images, generated music.
So B, more layers, doesn't guarantee authenticity.
Yeah.
C is classification, not generation. D is a different learning type.
Correct. More layers mean deeper, not necessarily more authentic in the GAN context. Grouping classification is different. And trial-based learning points towards reinforcement learning, another paradigm. The core is that adversarial simultaneous training.
So what this means for you is that GANs are behind a lot of sophisticated AI, creating synthetic data or realistic media. Understanding this battle helps grasp their power, but also the risks, like realistic fake content.
Both the potential and the peril, yes.
All right, let's shift back to the organizational side. How do you get people on board with AI? What approach would most likely improve employees' attitudes toward embracing AI in an enterprise?
The human element, always crucial.
Options. A, developing strong AI acceptable use policies, AUPs, and ethical standards. B, training technical staff on model development. C, providing training and assigning department champions to address changes. D, referencing established AI frameworks and ensuring regular audits.
All potentially useful activity.
But which one really targets attitudes?
I'd say C, providing training and assigning department champions.
Okay, why C over the others? Policies, A, and frameworks, D, seem important for structure.
They are important for governance and compliance, absolutely. But they don't necessarily change how an employee feels about AI impacting their job or daily work. Policies can feel top-down, frameworks abstract.
In training just the tech staff, B is too narrow.
Exactly. It helps the builders, but not the users or those affected indirectly. Option C addresses the human side directly. Enterprise-wide training helps everyone understand the what and why of the AI.
And the champions.
That's key. Having department-level champions, trusted peers, creates a local resource for questions and concerns. It fosters transparent, open communication, which can really alleviate anxieties about job changes or new processes.
So it tackles the fear and uncertainty head-on.
Precisely. It's about managing the change, addressing the human anxieties and opportunities directly. Policies and audits support it, but C is about winning hearts and minds.
That makes sense. It really raises the question, how do you get genuine buy-in? It's about managing change.
People, not just tech.
Okay, closely related then. What is a key reason for integrating workforce analysis when considering AI use in an enterprise?
Workforce analysis, very important.
Is it A, to determine the financial impact by department? B, to navigate changes in roles and upskill employees? C, to facilitate higher-level decision-making? Or D, to ensure departments follow established guidelines?
The key reason here, focusing on the workforce, is B, to navigate changes in roles and upskill employees.
Explain that link.
AI implementation isn't just about adding tools, it changes how work gets done. Roles shift, some tasks get automated, new skills are needed. Workforce analysis is about being proactive about that.
So anticipating the human impact.
Exactly. Anticipating how roles will change, identifying skill gaps before they become problems, and planning how to retrain or upskill your existing employees so they can transition smoothly.
So it's not primarily about cost A or decision-making C or compliance D.
Financial impact A is a factor, but not the core of workforce analysis. AI might facilitate decisions, C, but the analysis itself isn't aimed at that directly. Compliance, D, is a separate function. Workforce analysis is squarely focused on the people, their roles, skills, and future within the AI-augmented organization.
This highlights that successful AI isn't just tech deployment. It's about reshaping the human landscape thoughtfully. seeing AI as augmentation.
Right. And preparing your team for that future, ensuring they have the skills and knowledge needed. It's about a smooth transition.
Okay, we've covered a lot of ground in governance and risk. Let's take a quick pause and synthesize what we've unpacked so far.
Good idea.
We started with the practical goal of AI integration making it usable, then the strategic need for frameworks to ensure alignment. We hit the black box risk of deep learning, the need for fresh data, the supervised versus unsupervised distinction, how JANs work.
And then the crucial human elements fostering employee buy-in through training and champions, and the importance of workforce analysis for navigating role changes and upskilling.
Right. It shows how AI touches everything from core tech to strategy to people management.
What's fascinating is seeing how interconnected it all is. Technical choices impact risk, strategic frameworks guide implementation, and human factors determine adoption success. It all falls under that umbrella of effective AI governance and risk management.
Each question points to a piece of that bigger puzzle.
Exactly. Success requires that holistic view, careful planning, continuous monitoring, and understanding all the implications.
So hopefully, you listening are feeling better equipped now to recognize these foundational elements that make AI work effectively and responsibly.
That's the aim, seeing AI not just as tech, but as a strategic asset needing careful ethical management.
So the final thought to leave you with as we wrap up this part. As AI races ahead, how will your organization ensure its solutions are not just powerful, but also fair, transparent, and resilient against changing data and new challenges? Something to ponder.